Hello friends, so in today's question, consider two blocks as shown in the figure. A force is applied on the lower block. So these are the four questions based on this figure, in which 2 kg is the weight of upper block, mu1 is the coefficient of friction between 2 and 4 kg. A force F is being applied on the lower block whose weight is given as 4 kg, and coefficient of friction between the 4 kg and the ground or surface is given as 0.1. So first is, where does the sliding begins first? B part, what is the minimum force at which any part of the system starts sliding? C part, at what value of force F will the sliding start at the other surfaces? For the following values of F, find the acceleration of the two blocks, nature and value of friction at the rough surfaces, and these are three values of the force, and for each value of force we are going to find out what is the value of acceleration, nature and the value of the friction between the two blocks and also between the block and the ground. So first of all, let us find out what will be the value of the friction between 2 kg, 4 kg and 4 kg and the ground. Okay. So let us draw a free body diagram. So this is our 2 kg and this is our 4 kg. A force F is being applied on 4 kg block. So because of that, a frictional force, let us call that Fr1, will be acting on the 4 kg block. Now this applied force will try to move 2 kg along its direction. So there will be a force, let us call friction force, Fr2, acting on 2 kg, and equal and opposite will be acting on the 4 kg, that will be also Fr2. Okay. So, and we are assuming that because of this force, this is the direction of the motion. And now let us find out the Fr1 as well as Fr2. Okay. So you can say our Fr1, which we can call it as Fr maximum also, will be equal to mu1. The weight will be 4 plus 2 and multiplied by g. Mu1 is 0.1 and we have this as 6 into 10. So we are going to get the Fr1 or Fr maximum will be equal to 6 newtons. And similarly, we can find out Fr2, let us call this F maximum value also, will be equal to mu2, 2 kg, and g, and mu2 is 0.2, 2, and this will be 10. So we are going to get this value as 4 newtons. So we have the value of the friction Fr1 as 6 newton and value of friction Fr2 as 4 newton. Now let us consider part A, in which it is asked that where the sliding begins first. Okay. So in this case, for A, you can say that force F is being applied on 4 kg block. Force is being applied on the 4 kg block. It means that so you can write it this way, that when F becomes greater than force of friction, that is FR1 block 4 kg. Let me write it other way. You can say that the force F is being applied on the 4 kg block. If 4 kg block starts to move, or we can say accelerate, then only two kg block will move. So under this condition, because as the force is being applied on the 4 kg, so first of all the 4 kg block has to move. If the 4 kg block doesn't move, the 2 kg block will not move independently. The 2 kg block will move in cohesion with the 4 kg block. Okay. Therefore 4 kg block starts to slide first. So this was our A part. In the B part, it is asked that was a minimum force at which any part of system starts sliding. Okay. So in the B part, we are going to find out what will be the minimum value of the force F. Let us do B part. States that now we already concluded that the 4 kg block will start sliding first. Okay, so we can say 4 kg block will start to slide first. And we are supposed to find out what will be the value of the force. Now the force of friction, or we can say maximum force which will be acting, can only be 6 Newton for FR1. Okay. So we can also say from here, if both blocks 4 kg and 2 kg are moving together, then we have this our 2 plus 4 kg, and force F is being applied on it, and there will be a frictional force FR1 that will be acting on it. Okay. So the applied force should be able to overcome the FR1 friction, then only the 4 kg will start to slide. You can say if F is greater than F1, 4 kg will start to slide. So which basically means that F should be greater than 6 Newton. We can say the minimum value of the force is equal to 6 Newton for 4 kg to slide. So this is our B part. In the C part, we are supposed to find out at what value of force F will the other sliding start at the other surfaces. Okay. Now we are going to find out what will be the when the other parts start to slide. So before that, let's find out the acceleration of the respective blocks. Okay. So you can say that for 2 kg block, so you can say for 2 kg block, sorry, so for 2 kg block, its acceleration let us call this A2. Okay. So we can find out the 2 kg block, the applied force on the 2 kg block is because of the friction Fr2, and we are saying its acceleration is A2 in this direction. So we can say that Fr2 is equal to 2 kg to A2, and Fr2 is also given as mu2 into 2 kg into g. So 2 cancel out with 2. So from here we can say that A2 will be equal to 2 meter per second square. So this is the acceleration for the 2 kg block. Okay. Now, which means that this is the maximum acceleration with which 2 kg block can move. Which also means that the total acceleration of the entire system should be also 2 kg. Which also means that the maximum acceleration of 2 plus 4 kg will be 2 meter per second square. So which basically means that if this is of 2 plus 4 kg, a force F is being applied on it, and it can move only with the acceleration of 2 meter per second square, and Fr1 will be the value of the friction. So we can write this equation as F minus Fr1 will be equal to mass into acceleration, that is 6 into 2, and we already know value of Fr1, this will become equal to 12, and we know value of Fr1 maximum is 6 Newton. Okay, let me write here Fr1 will be equal to Fr1 max, as it is sliding, so it will be Fr1 max, which is equal to 6 Newton. So from here we can say that the applied force F will be equal to 12 plus 6, which is equal to 18 Newton. Okay. So this F is equal to 18 Newton. So from here we can draw an important conclusion that let me write it here, F is greater than 18 Newton. Okay. Rather, sorry, F is equal to 18 Newton. This is the value of the force on the entire system. Now if the applied force or rather we can say sliding between 4 kg and 2 kg will start if they have different accelerations. They have different accelerations, and we already found out that for same acceleration applied force should be equal to applied force F should be equal to 18 Newton. So it means that as soon as F becomes greater than 18 Newton, sliding starts between 4 kg and 2 kg. Okay. Sliding start between 4 kg and 2 kg. So this was our part C, because it was asked for what value of force F. So we can write here that when F is greater than 18, sliding starts between 4 kg and 2 kg. So this completes our part C, and now we come to the part D. In the D part, we have to take different values of force, first 3 Newton, then 12, then 24, and find out the value of the friction, nature, and the acceleration in the two blocks. So let for first part, F is equal to 3 Newton. So the applied force is 3 Newton, but Fr1, which is equal to Fr1 max, is our 6 Newton. So from here we can say that applied force F is less than Fr1 max. So as long as applied force is less than the frictional force, there will be, the acceleration will be 0 basically. You can say acceleration of 4 kg will be 0, or also we can say acceleration of 2 kg will be also 0. So we can say that acceleration of 2 kg and acceleration of 4 kg will be 0. So this is the first part. The second part, the value of applied force is 12 Newton. Value of the applied force is 12 Newton, and this value of applied force is less than the 18 Newton. Okay, you can say applied force is less than the 18 Newton. So under this condition, both blocks will be moving with the same acceleration. Both 2 and 4 kg will move with same acceleration, this is about 2 plus 4 kg. Applied force is F, which is here 12 Newton. So we have FR1, which is equal to FR1 max, and this will be equal to 6 Newton. And let's suppose they have acceleration A in this direction. So they have same acceleration, so you can say A2, A4 is equal to A, and which is equal to F minus FR1 max divided by 6. So applied force is 12, FR1 max is 6 divided by 6. So our A2 will be equal to A4, which is equal to A. This will be coming as 1 meter per second square. So this is the acceleration for F is equal to 12 Newton. And the last part, third part, applied force F is given as 24 Newton. From here we can say the applied force is greater than 18 Newton. Under this condition, both blocks will be moving with different acceleration. Both blocks will move with different acceleration. Okay. So let us do it for, first of all, for block 2. So this is about 2 kg, and we have this FR2, and acceleration is A2 in this direction, and we already know that FR2 will be equal to FR2 max, which is equal to 4 Newton. So we have FR2 is equal to A2, so we can say 4 is equal to 2A2, so it means our A2 will be equal to 2 meter per second square. And for 4 kg, we have this FR2, applied force is F, we have FR1, and let us suppose acceleration is given A4, and here the FR1 will be equal to FR1 max, which equal to 6 Newton, and FR2 is FR2 max, which equal to 4 Newton. So we can write the equation as applied force is 24, so you can say F minus FR1 minus FR2 will be equal to 4 into A4. And we can say our A4 is equal to 24 minus 4 minus 6 divided by 4, so it will be equal to 14 by 4. So we can say our acceleration A4 will be equal to 7, so this will be 3.5 meter per second square. So this is our acceleration of 2 kg, and this is our acceleration of 4 kg. So this is a wonderful example for which, especially the part D, we can clearly see how the application of the force for different values, the value of the acceleration changes from 0 to a common value, then the different value, and accordingly the value of the friction also going to change. Thank you.